Hello, Assalamualaikum. Hi, my name is Muhammad Hazim bin Nur Helmi, and my metric number is DCA30093. And this video is about case study in geotechnology. And first, I'm going to talk about definition of slope. Slope is the angle of inclination of soil surface from horizontal. Next is definition of slope stability. Natural and man-made slope are the two most common forms of slopes. Physical processes such as plate tectonics and weathering, erosion of rock masses result in material deposition, resulting in natural slopes. Artificially created slopes are used to help with infrastructure projects such as embankment, earth dams, and road cuttings, among other things. The term slope stability may be defined as the resistance of inclined surface to failure by sliding or collapsing. The main objective of slope stability analysis are finding and dangerous areas, investigation of potential failure mechanism, determination of the slope sensitivity to different triggering mechanism, design of optional slope with regard to safety, reliability, and economics designing, possible remedial issue, example, barriers, and stabilization. In geotechnical engineering application, the stability of a slope is crucial. A landslide, also known as a slope shift, can cause serious problems such as infrastructure damage and casualties. Slope stability is determined by the soil mass ability to endure gravity forces as well as additional loads acting on the slope and potential dynamic loads such as that of an earthquake. Next is objective of slope stability. The main objective of slope stability analysis are finding enriched areas, investigation of potential failure mechanism, determination of the slope sensitivity to different triggering mechanism, designing of optimal slope with regard to safety, reliability, and economics. Designing possible remedial measures, example, barriers and stabilization. And next is type of slope failure. The first is faults. Faults are sudden downhill motion that are not preceded by any beginning movement or warnings. They happen when a stone mass breaks away from a slope along a discontinuity plane, which can be caused by fractures, joints, or bedding. The shear strength of the discontinuity plane, which is reduced by mechanical weathering propagation, and the presence of water controls the fault. A rock boulder will follow a specific trajectory once it has been separated, which is determined by its size and shape, as well as the geographical of the area. The type of movement can be free fall, bouncing, rolling, or a combination of these. Here I put some picture you can see at the slide. Types of slope failure. Number 2 is rational slides. Rational slides are more common on slope with very homogeneous clay. The failure surface is frequently curved and deep and treacherous. Figure 2 shows how the sliding mass slumps, dropping at the back and having at the toe. Down-circular rational slopes are linked with natural slope of over-consolidated clays in which weathering has generated a softer upper layer, whereas approximately circular rational slopes are associated with cut slopes of homogeneous clay. Here I put the picture, as you can see at the slide. And number 3 is translational slides. Translational slides are usually caused by the existence of heterogeneity in the form of a weak soil layer beneath the slope at a shallow depth. Figures 3 show the failure surface, which is roughly planar and parallel to the ground surface. A compound slide of partly rational and partly translational character may develop if the plane of weakness is at a moderate depth beneath the slope. I also put some picture of the translational slide. And the number 4 is flows. Flows are mass movement with no clearly defined failure planes. Earth flows and mud flows are distinguished by Skempton and Houskingen 1969. The latter have a glacier-like appearance, whereas the former are regarded as transitional in nature between slide and mud flows. There are four types of flows. First, debris flow, debris avalanche, earth flow, and the fourth one is creek. I also put some picture of the types of the flows. And next is factor of slope failure. The manner in which a slope fails is chiefly controlled by the following factors. First, geological. Second, hydrological. Third, topographical. Fourth, climatic condition. And fifth is extent of weathering rocks or soils. Next, we move on to the case study. This accident happened at construction site in Tanjung Bunga, Pulau Pinang, which is suburb of Georgetown in Penang. It happened on Sunday that killed 11 site workers. Workers from Indonesia, Bangladesh, Myanmar, and Pakistan, as well as a Malaysian site supervisor, were killed in the collapse, which occurred at the construction site for two 49-story residential complex. This is the greatest photograph I've seen of the collapse, courtesy of the Sun Daily. Here, I put some picture that been photoed by Sun Daily. Inevitably, this big failure has sparked heated debate in Malaysia, with questions being raised regarding at the pace at which development in hill slope areas is taking place. I believe that one of the most important aspects of the study will be the slope protection measures that were in place. It is apparent that significant slope cutting was done in order to develop the apartment site. I find it strange that these cuts, which look to be made of weathered materials, appear to have only limited precaution in place to maintain the slope stability. Interestingly, some drone image obtained at the site in July by Malaysia Star newspaper appears to reveal that this area of the cloud slope were experiencing stability issue. Landslides have a long history in Malaysia, with some of them being linked to significant construction projects. Malaysia published a national slope master plan in 2012. However, it is unfortunately no longer available online. According to news report, the Department of the Environment rejected the project's design in 2015. To investigate the landslide, a commission of inquiry has been formed. And the last one is conclusion. Landslides are hazardous, interrupt development, and are expensive to restore. As a result, they must be accurately appraised. The limit equilibrium method is the most popular strategy employed in the deterministic analysis of slope stability problem. The shear stress mobilized along the trial failure surface is compared to the shear strength to calculate the factor of safety. The failure surface is assumed to have the same factor of safety value, which does not provide any information about the level of strain. When deciding on an acceptable value for a factor of safety, the reliability of the parameters of the repercussion of failure should be considered. That's all from me. Thank you.